Welcome, this is Ad Emmen reporting live from our downtown Almere studio. And today we are talking with Xueri Mao and Bruno Carmo from the HPCWE project. So, Xueri, can you please tell what the project is about?
Okay, thank you very much, Ed. So I'm the project coordinator of high-performance computing in wind energy. So in this project, we have 11 partners. 8 of them are from Europe and 3 are from Brazil. This consortium covers SME, industries, HPC centers, and universities. Our objectives include to promote the application of HPC in wind energy and to promote the joint collaborations between Europe and Brazil in both academics and industries.
Okay, and when you talk about wind energy, what do you mean with wind energy?
Yeah, in wind energy, HPC is a must. So in several stages of wind energy, we have to use HPC. So for example, when we design the turbine blades, the simulation of flow around the blade is critical. In the wind farm scale, larger than the turbine blade scale, we also need HPC to figure out the optimal layout of wind turbines in the farm. Then in a larger scale, in the 1,000 kilometer scale, which is also called mesoscale, similar with the weather scale, we can also run large scale simulations to predict the overall wind resources so as to pre-construct a wind farm. So this is to say there are several levels in wind energy where we need HPC. So from the smallest scale in flow around the blade to the largest scale in the weather scale.
And yeah, I saw pictures of that. So you basically module everything from, let's say, the blade and the tip of the blade to large-scale wind energy plants. Is that correct?
Exactly. So the scale integration is a critical component of the work. And we cover this long range of scales where HPC are required in the development of wind energy.
Okay, yeah, then I understand why you need that. There are lots of simulations already of parts of it, but you collect everything together from the small to the large. Yeah, very good. This is a European Brazil project. So, Bruno, can you please explain a little bit about that?
Yes, sure. Brazil is collaborating in this project with the European partners for many reasons. I think the first of them is the large wind energy potential that we have here in the country. As opposed to what happens to European countries, we still have some onshore potential to be explored. A lot of onshore potential to be explored. So wind energy is growing very fast here in Brazil. And there are many engineering and technology challenges to be tackled. And it would be nice to use high-performance computing to help to solve those issues. Okay? And besides the onshore capability, we are also starting to develop the offshore capability. We don't have offshore wind farms here in Brazil yet, but we have many planned to be constructed very soon. Okay, so in terms of the industry, it's very strategic to Brazil, for Brazil to be part of this project. And besides that, we also have a growing community in the academia working with wind energy, and to be very strategic for us to also partner with European institutions that have a long-term tradition in this area. And we could benefit from this collaboration and also offer some of the work that we are developing here in terms of capacity, people, and software. And so for us, it's very interesting to be part of this collaboration. I think it's a win-win situation for the European and Brazilian partners, both in the terms of the academia and industry.
Yeah, is it, when you look at Europe and Brazil, is it then that in Europe there's more offshore wind parks and Brazil more onshore, or is that
in terms of what's being developed now, yes. A lot of the development in Europe nowadays is offshore because many of the onshore sites are already producing energy. Okay, so there are not so many onshore sites available nowadays. There are some, but not a lot. And Europe has been developing its offshore potential for quite some years now in the North Sea mainly. And so there's a huge potential there to be explored. And in Brazil, we have offshore potential as well, but also some onshore locations that are still waiting to be explored. So we have both here. The wind energy started later here than started to be explored later here than it was in Europe. So that's why we are lagging behind in terms of the time. We have a very clean energy matrix already because we have a lot of hydropower here. So the pressure for using wind energy here, was not so strong as in Europe. So that's one of the reasons why it wasn't developed so fast here. But since 10, 15 years ago, we have been investing a lot on wind energy, and we see a steady growth of this technology here in Brazil.
And when you're talking about developing models and using HPC for these for the wind energy, are you then talking mostly about using HPC, or are you more focused on developing algorithms?
Yeah, there are several levels. So we use advanced HPC architectures to test our codes. So those facilities are offered by the UK National HPC Centre, EPCC, hosted by Edinburgh University, and also in another partner hosted by the University of Stuttgart. So here, the work is related with hardware architectures. Well, another level is the development of codes with exascale potentials. So we identified the codes with such potentials, and we identify the key criterion, KPIs, to develop those code for the next generation wind energy prediction tools. And in another level, the third level, we use some commercial or very mature codes, we modify them, and we test them in typical wind farm sites. So for example, we have selected one in Europe and another one in Brazil to match the interest of both the partners, the European and Brazilian partners.
And so the project is now, I think, about midway, isn't it? About halfway?
It is around the middle.
Yeah. So can you tell a little bit about what, and you just had a workshop around it. So can you tell a little bit about the results that you achieved thus far?
Yeah. So we have developed many advanced algorithms and installed them into several of the codes, the flagship codes, and tested them using the 3 use cases. So for example, for wind resource assessment, which is critical for the pre-construction of wind farms, using our advanced technologies, we can reduce the prediction error by around 50%. Previously, we used the mesoscale simulation to make the prediction. Now we can have data fusion technology, which will significantly reduce the computational cost, or when we use the same cost to lift the accuracy significantly. So this is one of the examples. Some other examples include the model of the wind turbine and the wind turbine aerodynamics and its structure dynamics. We call it aeroelastics. Some other examples, such as the prediction of uncertainty and qualification of the uncertainty, and the optimal layout of wind farms, the advanced model of wind turbines, and so forth. So there are several advanced techniques and codes under development. For the dissemination activities, we have presented our work in several conferences, and there are several papers accepted and under review. We also held a midterm project workshop where we have had over 200 attendees. All the presentations, the videos and the PowerPoints are attached to our website, the HPCWE website.
Yeah, I saw that there were yeah. So I didn't know the number, but 200 sounds like really a lot of people. I mean, working on in this area, and so it's nice. It was a virtual workshop, so everybody could indeed attend. That is also very nice. Are there specific things that were discussed at that workshop that you say, well, this is new, or this is a very good work that we did, which were highlighted, or?
Yeah, so one of the work we highlighted is the efficient simulation of the joint joint simulation of aerodynamics and the structure dynamics. So we coupled two solvers, which is managed by our partner at Imperial College London, joined by University of São Paulo, which Dr. Bruno Carmo is leading. Another work is between Nottingham and Technical University of Denmark, DTU, and we applied the WRF data collected from large-scale numerical simulations and some limited measurements to create a data fusion. So those are the techniques we would like to highlight. Of course, there are several more, such as the quantification of uncertainties of wind farm power output induced by the oscillation of the free stream wind condition. You know that the wind changes with time strongly, so maybe it can be 2 meters per second, and 1 hour later it would be 50 meters per second. So this would induce the power curve to fluctuate. So in this project, we developed a framework and applied it to identify such fluctuations and to quantify the uncertainty.
So yeah, we know, I mean, we are here in Almere and we know a lot about wind changes. Actually, we call it most of the time a breeze. We have light breezes and strong breezes. We don't call it wind, but people that come here call it wind. So we know a little bit about changing winds, etc. So Bruno, can you tell a little bit perhaps about the work that you do specifically, and whether that has specific relations to Brazil, or is it just part of the overall work?
Mm-hmm. No, yeah. In Brazil, we have three main partners: the University of São Paulo, from where I'm from, University of Campinas, and the Federal University of Santa Catarina. So each partner has different capabilities. In the case of University of São Paulo, we are collaborating with Imperial College London, as Xueri just mentioned, on the modeling and simulation of the turbine at the blade scale. Okay, so what's called blade resolved simulations, and also using actuator line modeling to perform simulations at the wind farm scale. Okay, so all of this is called micro scale for the wind energy community. The people from Unicamp, the University of Campinas, they work more with optimization and sensitivity calculation of the wind farm layout. Okay, so the capabilities are more focused on the optimization part of the project. And the Federal University of Santa Catarina, they have been working on the integration between meso and micro scale, and also providing some field data to do some studies in terms of a possible offshore location for a wind farm in Brazil. So they have a team there with some LiDARs, those sensors that measure the speed of the wind in different heights. And we are providing this data so we can test the models that are being developed in the project. So we have different institutions with different capabilities, and we are trying to make the best matches between the European and Brazilian partners to get the best value out of the project. So
it all sounds like there's already a lot of progress. So what are the things that you will do in the coming, is it about a year of the project?
Yeah, please, sorry.
You go.
I can complement after.
Okay, yeah. So in the next year, our top priority is to focus on the codes with exascale potentials and try to develop that. Those codes are firstly developed in Europe, and apart from the exascale potentials, they also have good capacities and good applications in wind energy using the three user cases we have defined in this project. So the development of exascale codes is our first priority in the next 1 year, while some other parts include further development of big data analytics skills. So for example, we want to reduce the data storage, in wind energy. For example, when we want to construct a farm, the wind may come from various directions in each season. So we want to test the wind in 10 years. So this means you have a huge amount of data to store. And then we want to develop a technology to reduce this data. We want to extract only the key dynamics, the key models of this complex flow. If we have a mountainous region, then the flow is really complicated. It's three-dimensional, and we want to use the big data analytics skills we are developing here to reduce the size of the data so as to facilitate our project and to reduce the data to save during the simulations.
Yeah, if I can complete. So in the Brazilian side, many of the developments that were carried out in the first year were like concept tests. So we had to put the team working together, do some benchmark tests. And now the second year will be more about production in terms of, okay, let's take it to the exascale, as Xueri just mentioned. Let's solve a very complicated case. So I see the development of the project as a whole as first year is about preparation of things. And then the second year is about production and use of the tools that have developed to cases that are at industry level. That's like that.
Well, I'm really looking forward to see the results of the project, and I hope to talk to you both again then. Thank you very much.
It will be a pleasure.
A pleasure.
For Premier Magazine, this was Artemen talking from a windy Almere.